Hello viewers, heat and temperature question 2, and we've got some values at the top that we need to find the energy required to heat 5 kilograms of ice from a temperature of negative 50 degrees Celsius to steam at a temperature of 110 degrees Celsius. And we're advised to include a heating curve in our answer. So let's draw the heating curve to begin with, because that will give us a good idea of what's happening in this question. So the heating curve is going to be a graph of temperature versus time, and we're starting off at a temperature of negative 50, and the first stage of the process is going to be the solid ice, which is going to be increasing in temperature up to melting point, which is going to be 0. So the first stage is when ice warms up from negative 50 up to 0. Then the second stage is going to be when all of the ice melts, and during that part of the process there will be no change in temperature. All of the heat energy will be going into that phase change between solid to liquid. Once all of that ice is melted though, it's going to be all in the form of liquid water, and it's going to begin increasing in temperature again until it reaches boiling point at 100 degrees. Once it reaches 100 degrees, it's again going to undergo a phase change from, this time, liquid into gas. So it's going to be converted into steam. As it does so, again, as it's a phase change, there is no change in temperature. And lastly, once it's all in the form of steam, that steam is going to increase in temperature up to 110 degrees. So there are 5 stages here. The first stage is the increase in temperature of solid ice, which is going to be, since it's an increase in temperature, the formula is Q equals mc delta T. M here is 5, it's a 5 kilogram block of ice, multiplied by the value of C, which for ice, the specific heat is 2.1 kilojoules per kilogram Kelvin, multiplied by the change in temperature. For this phase, for this stage, it's going from negative 50 to 0, so that's a change in 50 degrees. And if we calculate that, we get 525. The values we're given are in terms of kilojoules, so this will be in kilojoules. Second stage is the phase change when the ice melts. So as it's a phase change, it's Q equals mL, and solid to liquid means it's LF that we're using here, the latent heat of fusion. The mass is 5, multiplied by LF is 334, and if we calculate that, we get 1,670 kilojoules. The third stage, now all of the ice is melted. It's now liquid water, and it's going to increase in temperature, so we need up to 100 degrees, so we need mc delta T. We've still got 5 kilograms. We're now using liquid water, which has a specific heat of 4.2, and the change in temperature for this stage is 0 up to 100, so that's a change of 100, and if we calculate that, we get 2,100 kilojoules. So now it's at 100 degrees and it's about to become steam, so it's a phase change we're looking at. Q equals mL, and it's vaporization, latent heat of vaporization, because it's the phase change from liquid to gas, which is, mass is still 5, LV we're given to be 2,258, and this is by far the most energetic part of the process. If we calculate that, we get 11,290 kilojoules. And lastly, it's now all steam. It's just a matter of heating it up from 100 to 110. So this is going to be mc delta T, The mass is still 5 kilograms. For steam, we're given the specific heat is 1.996. Change in temperature for this part is just 10 degrees. It's going from 100 to 110, which is 10 degrees. And if we calculate that, we get 99.8 kilojoules. So the last thing we need to do is work out the total energy, which we can just get by adding up 525 plus 1,670 plus 2,100 plus 11,290 plus 99.8. And if we do that, we get 15,685 kilojoules, which is 15.7 megajoules. Okay, thanks for watching. Over and out.